Welcome to the demonstration of the Energy Aware Backpressure innovation of the six-screen project. Energy Aware Backpressure is the innovation allowing the three domains to come together and cooperate towards joint sustainability goals. It entails a combination of mechanisms for the computation of the resources and consumption ascribable to an application and its slice, as well as the definition of green business models to showcase the mutual benefits for all stakeholders. To operate, energy-aware backpressure requires information and decisions that involve the cooperation of components belonging to the three domains of the 5/6G ecosystem. This video uses the desktop as a service use case as an example to showcase EAB. The VAO is used to create a new instance for the application and request a slice accordingly. First, the network provider and the location are set for each component of the application. Then the QoS parameters related to the slice to be created are selected. The VAO is waiting for a response from the BSSF to confirm the creation of the slice and the assignment of the computing resources to proceed with the deployment of the application. The deployment is now launched. We can see on the command line interface that the 4 pods composing the deployed application are up and running. The terminal shows the 4 application components have all been deployed on a red node, as requested in the slice intent request. It can also be noticed that other nodes are available in the infrastructure, some tagged red and some green, which means that the hosting servers are served by a renewable energy source. The implemented mechanism to enable EAB regards the definition of policies that exploit the app-level KPI exposed by the rating operator for the zero-touch reconfiguration of the application. In this case, the policy consists in migrating the application components to a node served by green energy if its consumption overcomes a certain threshold. The policy is defined on the VAO and applied to the desired application. First, you define the policy, then the observed metric, the policy to be applied above or below a certain threshold, and the threshold itself, that in this case is 60 watts. When the threshold is met, it triggers the type of action migration to a green node. The rating operator enables the transformation of metrics collected at different architectural levels into customizable key performance indicators allowing users to define rules for this conversion. For instance, metrics related to computing resources can be exposed as KPI representing energy consumption, carbon footprint, or pricing. The policy that was just configured on the VAO is automatically reported on the Prometheus exporter in charge of exposing the metrics collected by the rating operator. We can see that the power currently consumed by the application is 53.7 watts. Now let's see what happens if the consumption is raised by doing some operations on the application, for instance, watching a YouTube video on the desktop as a service. So we just start playing a video and let it run. Additional details on the desktop as a service application can be found in the dedicated video. We can now see that the consumption has overcome the threshold that was defined on the VAO. Let us verify that the migration has started. On the command line, the kubectl get pods command shows that all the pods composing the application are still running on the previous node, and the video on the remote desktop is still running. Moving back to the command line, now the pods are being migrated to the target green node. Now the migration is complete. As we can see, the destination node is one served by green energy,